Hey everyone, welcome to another live coding. Um, in this live coding, we will be predicting people's ages just based on their faces. And we have a baseline model which we can go through, where it, for training, predicts it within just 4 years of range on average by the end of it. But it did have some trouble with the validation, so we'll play around a little bit with dropout and see where we can get there as well. Then we might try another architecture if we have time for that as well. But let's just get straight into it. So first thing first, the data set and the baseline model comes from this blog, which is image recognition, age prediction based on images. And they have some nice details in here. The main part which we're going to take from that is this data set, the UTK-F phase, UTK phase, sorry for mispronouncing that, which has a bunch of different images of people cropped on their faces. We have their age, we have their gender, the race, and the date and time as well. We'll only be using the age though, as that's all we're going to need. And we can take a quick look at the data set here. So I already prepared a CSV file for it, which is what we're going to use to read the data into PerceptiLabs. And we'll take a look at the CSV file in just a second. But besides that, we have this folder images, which is exactly a folder from the website. So as we can see, we have a bunch of babies ranging all the way down to some 8-year-old, 14 years old, etc., etc. There we go, all the way down to people of age 110. So we get a pretty good variety here. And the CSV file then, all I did there was just take the name of the image and then take as a label or as the second column, I took these first 2 digits, or first before everything before the first underslash. And then it looked something like this, where we have all the images and we get the age of it, which correlates to the name of the image. And that should be everything we need to get this into PerceptiLabs and start building a model from it. So let's get started with that. All right. So I have this spun up on a GPU machine where I already preloaded the data. And we'll, as usual, we just load the CSV file into PerceptiLabs, and we'll then get this little preview of what it contains. We already know, since we looked at the Excel, but we can just verify that everything looks as it should. We'll put the first column as input. That's what we want the images to go into the model. And we'll put these ones as the output. I think we're going to rename these as targets, since it's more it's not really the output of the model. The output of the model is more the last layer, while this is the target we want the output layer to hit. We'll see if we do a small rename there. Then we have the type, which here are images. And in the first one, already is correct. We don't want to run classification this time. Instead, we're running numerical, since we'll be doing essentially a regression problem, image regression problem, by looking at the image and trying to predict a number based on it. All right, and then we'll create a model. Okay, so here is our baseline model, which may or may not work very well, but the model we're going to try first is a similar one to the blog I showed before used. And what I did there is they took a ResNet followed by a few dense components. So let's do that same thing. So we have a ResNet, we don't really need any other settings in it. And then we plot down 1, 2, 3 dense components. Oh, that's one too many. And these ones, since we're not training the ResNets is essentially just a pre-trained layer which we'll use for feature extraction. We're going to use this entire part as the trainable part of the model. So in here, we're going to have a pretty sizable model. We'll have 512 neurons in the first one. I'm going to use ReLU on both of the hidden layers. And then here we go down to 16. And finally, we have an output of 1. I'll connect that to the output layer. And there we go. All right, so that should be everything we need to do with the model. So we can give this one a test run and see how it works. I think even just 5 epochs is enough for this one. It's a pretty sizable data set. Oh, the volume is quiet. Let me try. Let's see like this. I just recently got a new microphone I'm trying out. Is that any better? Okay, hopefully it's a little bit better now, otherwise I'll increase it a bit more. It's strange, I ran it just before and did a recording and played it back to myself and it sounded fine. Can bump it up even a little bit more. All right, hopefully you guys can hear me better now. Let me know otherwise. But jumping back into the model, we then have, as I was saying, it's such a large data set, so I think even fewer than 10 epochs may be enough. We can try out with 10 and see how that works first. And we usually go over to cross-entropy loss, since we're now doing a regression problem. We'll be using quadratic loss instead. And we'll also use the loss as a measurement of how close we're getting to the values. And we can start running.